A box of mass 5 kilograms lies on a rough plane inclined at 30 degrees to the horizontal. The box is held in equilibrium by a horizontal force of magnitude 20 newtons, as shown in figure 2. The force acts in a vertical plane containing a line of greatest slope of the inclined plane. The box is in equilibrium and on the point of moving down the plane. The box is modelled as a particle. Find the magnitude of the normal reaction of the plane on the box and the coefficient of friction between the box and the plane. Okay then, I've got the question summary form here, so let's have a little look at it. So I've put in all the information from the question, so we just need to put in what the question further tells us. First of all, the weight, which is going to act down here, and that's 5g acting downwards. There's a normal reaction here, perpendicular to the slope, which we can label as R. It's on the point of moving downwards, isn't it? So the resistant force will be acting upwards. It's on the point of slipping, so this will be mu R, acting up the line of greatest slope. Okay, so there's the forces involved. So this angle is 60, this angle is 30, isn't it? Okay, so it's in equilibrium, so we can apply F equals ma then. We want to find the magnitude of the normal reaction, so I'm going to apply F equals ma in this direction here. So let's do that then. So F equals ma then. There's no acceleration, so the resultant force is 0. So F equals ma gives then R minus this force here, 5g cos 30, and there's no other forces. Oh, there's this here, so it's minus 5g and then minus 20. This was horizontal, wasn't it? Okay, so this is 30, so this will be 60, so it's minus 20 cosine 60 equals 0. So there's our forces then, and the resultant force is 0 because there's no acceleration in the system in equilibrium. So that tells us what R is. Move this over to be plus 5g cos 30 is root 3 over 2. And plus 20 times cos 60, which is sine 30, which is a half. So that's 10. So R is equal to then. So it's 5 times that g, 9.8, times by root 3, outside the square root, divided by 2. There's that, plus 10. Plus 10 equals 52.43, 52.4, and that's to 1 decimal place, newtons. So there's the reaction force then, normal reaction. The coefficient of friction, so let's apply F equals ma again in this direction here, along the line of greatest slope. So this is for part B. F equals ma again then. The forces are in equilibrium, so the resultant force is 0. So mu r was acting up the slope. So mu r minus plus the 20 cosine this angle, which is 30, plus 20 cos 30 then. Cos 30 is root 3 over 2, and then it's minus 5g cos 60, which is sine 30. 5g sine 30. Sine 30 is a half, and all those forces must equal 0. So mu r is equal to 5g over 2. Move that over. Move this over. The 2's cancel. It's 10 root 3. Move it over. It's minus 10 root 3. And then we can divide by r. So mu is equal to, 5g over 2 minus 10 root 3 divided by r, which was 52 point, let's get it back up on the calculator, 435. Keep it nice and accurate. Okay, so mu is equal to then, so let's keep that, that's in the calculator under answer, isn't it? So we'll keep that under ans, and we'll go for 5g over 2, 5 times 9.8 divided by 2 minus 10 times the square root of 3, that's the top number, divided by, oops, I pressed equals, 52.435, got it there. Or I can put it in here, so I'll put bracket, 5 times 9.8 times by the square root of 3, outside the square root, divide by 2, plus 10. That's the 52 number, equals 0.136, so that's 0.14, isn't it? And that was to 2 decimal places. And that's the coefficient of friction in part B.